You're listening to a Pub House Network podcast for developers by developers. Welcome to Java Pub House episode 96, everyone. Hey, I'm Freddie Guime. I'm one of the co-hosts here at the Java Pub House. For those who don't know me, I'm a principal engineer at Expedia, speaker, author, Java champion, and I'm here with my partner in crime, Bob.
Hi, Bob Paulin, independent consultant from Chicago, Apache Software Foundation member, Java champion, CJUG board chair.
Mm-hmm. And today is going to be fun because we're going to talk about something that is very enterprisey, but that you run everywhere. And sometimes there's so many things in flight that it's hard to understand and it seems like magic. But today we're going to sort of like peel off a little bit and then look at the magic. And this is essentially metrics collection. And for any kind of enterprise software you ever built, and even if you're a hobbyist, actually, like these are good things to have, right? It allows you to keep track of like how your application is doing, how much memory it's using, how many requests are coming in, how many, like how long are each of these requests taking. So all these sort of like data, sort of like what is called metrics collections, happen through a lot of the frameworks. And, especially the one that we're going to talk about is and there's like a big divide on how it's supposed to say it. I think the right way it is Micrometer, but some people call it Micrometer. That's what I used to call it for the longest time. But that's essentially what we're going to go over. And that is actually one of the most probable thing that is publishing metrics out of your application. And before we dive in, though, I wanted to thank our sponsor, which is actually pretty lined up with this episode, right? Because I think Micrometer actually has a Datadog endpoint where you can publish to. So today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 400 technologies, including AWS services, Docker, and Kubernetes. Datadog's platform brings together metrics, traces, and logs in one place so you can get full visibility into your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapubhouse.com/Datadog to get started. And again, the URL is javapubhouse.com/Datadog. And because you're going to learn about Micrometer today, nothing better than just go and sign in and start publishing to Datadog so you can see your dashboards in there. So that's going to be actually pretty fun. All right, Micrometer. Where do we start?
Well,
right?
So let's dive into what it is and what it isn't. So you've kind of touched on it that, hey, we're not just showing you the free version of Datadog, right? This isn't a complete replacement in general for your APM. This is an app instance specific view of your data, right? So what do I get out of this? I'm going to get information about the JVM. I'm going to get information from the app's perspective on how fast requests are being processed. I'm going to be able to look at metrics that, could be aggregated over a little bit of time, as well as some that are kind of just point in time numbers, where I may want another system that's going to pull those numbers in and create the graph for me. But this isn't going to exactly give you, the pretty view that we're used to looking at when we're monitoring applications in production for an enterprise company, right? This is just the piece that I, as an application developer, have control over. And in order to publish that information out and track that information, and maybe for local development, just maybe do a little bit of profiling and just kind of sanity checking on certain things within my app. And that's kind of what we're looking to cover here.
Yeah. I think like a flawed analogy will be like if you're driving a car, there's sensors everywhere, right? Like, you know, there's like the fuel tank sensor that tells you how much, you know, that says how fuel or empty the thing is. There is sort of like the wheel sensor that tell how fast things are speeding, you know, or spinning, or tire pressure sensors. And by themselves, they just emit numbers. Like they're just saying like, this is what the fuel is, this is what the speed is, this is what the PSI of your wheels are. And then essentially all these things get collected and then presented, right? And then if you're thinking about analogies, your APM, your monitoring, your metrics dashboard is actually, I think, like, you know, the analogy is perfect. It says that it is usually the car dashboard where you think about your APM view, where you can see things coming in and sort of like being digested in something that makes sense. You don't get to see like tire pressure, or you don't get to see like fuel is saying like 0.5 or 0.3 or 0.1. You get to see if it's full or empty, right? You don't get to see that you know that the PSI is exactly 13.5. Sometimes you just get a little light that says, you know, low pressure, instead of you trying to figure out what exactly was like the sensor said. So these sort of like this, what we're talking about is like this framework is essentially the quote unquote sensors of your application, where they'll produce these sort of like signals. And then most people, what they do is they take this onto like a product like, you know, Grafana, you know, Datadog, and then put together like ways for you to give a holistic view of, you know, and a historical view, like Bob says, because like the sensors they're small, right? They don't have any memory. They just admit what they see and they're done, right? But usually on a dashboard, you sort of collect them, and that's part of these collectors is to sort of create that history for you to then say like, look, how was my application behaving for the past month, for the past year? Some of them has the capability of doing multi-year sort of like historical information if you really need it to. So that's sort of like the fun part. This is essentially the lowest thing where the data collection starts.
Yeah.
Right.
And I think one of the, just to even build on the car analogy is, you know, when you buy a car, your car often comes installed with a bunch of pre-existing sensors. I mean, so a lot of application frameworks out there, Spring, Micronaut, Quarkus, they all have a lot of these hooks and these sensors already built in that you may be interested in. So you can get at this data without having to do a ton of work. But better than your car, what we're going to show you tonight is you're going to be able to create some of these sensors yourself. So, I mean, who would have thought to put a new sensor on your car to track something? If you're really good at IoT, hey, maybe you can do that. But these frameworks offer the opportunity that if there's something specific I want to measure that maybe is not in the framework and maybe nobody else cares about, we're going to show you how to add those things into your application to get at that low level data so you can bring it in to that overall dashboard. So not only do you get all of the stuff for free that the frameworks are providing if you choose to use a framework, but you also get your data augmented with it.
And let's start a little bit at the beginning, right? Like that we sort of have the idea of what this sort of like quote unquote sensors are, right? You know, essentially we call them metrics. Like this is not new, right? Like this has been going forever, right? And you sort of get this same situation that happened with logging. For those who remember logging back in 5-10 years ago, there were two competing sort of like big logging frameworks. Like there was Log4j, then there was different versions. So there was Log4j2, there was Logback, there was, Java util logging. Oh gosh. So they have all these things, right? And the same thing happened in the meter space. There is StatsD, InfluxDB, Datadog. There's two versions of StatsD, actually, the one from Etsy and the other one, I don't remember what it is. Prometheus, which is another sort of like data collection.
You're forgetting the very first one, though. What about JMX as far as the
JMX? That's the, we actually covered. Yeah.
We did.
Yeah.
We have another episode on that just covering JMX specifically, but it's of the same concept. So
what happened is like in the logging world, what somebody decided to do is create this quote unquote facade. And the facade essentially means that you only go to the quote unquote facade commands or interfaces. And depending on what you include on the back end, then the facade will accommodate, Java util login. It will accommodate log4j and accommodate logback. It will accommodate log4j too. So the idea is that all these other, it's almost like then it becomes a detail where you don't care what login framework it is. You just, use the SLF4J, and then in turn, as you compose your program, you can say, I want to change my login framework to be now this one. And SLF4J allows you to do that super, super easy, right? And a lot of the times also, if you are, for example, a library builder or you want to create libraries, sometimes you cannot dictate what kind of login framework you're going to be using, right? Because if your library is going to be essentially shoved into somebody else's project, then you sort of have to conform to what they do. And the easiest way to do that will be for you to quote unquote use a facade like SLF4J. So that happened in the logging world, and essentially that proved out to be very stable, super easy to use. All the people right now, I don't remember a project where I didn't that I skip SLF4J. That's how all my projects start now, right? They did exactly the same for all this sort of APM collectors and all this sort of metrics collector, where they created this quote unquote facade for collecting metrics, and they call it Micrometer. So Micrometer is a way for you to define the metrics that you want to collect, and then you sort of configure it to say look, I want you to publish my metrics into this way. I want it to publish as a JMX bean. I want you to publish as part of StatsD, Graph, InfluxDB, Prometheus, all these things. So you don't even have to worry about how Prometheus works or how StatsD works or any of these things work.
Sure. Or you code it to actually just publish them as an HTTP endpoint, and you have those other applications scrape, which is another very common way that this is done in Kubernetes, where you just have a bunch of apps, and the apps don't even have to be Java then, right?
As long as they have HTTP.
Micrometer is a JVM based tool, but the output, when you're just talking about the monitoring in general, can follow a standard format that can be used across different languages.
Mm-hmm. And the big one is what we want to do is let's just walk to let's walk to the example to start showing some of the sauce, and then maybe what we'll do is then we go back and describe what kind of things you can capture, right? Let's get into something fun and exciting so people can see, and then we go back and sort of tease it apart little by little. So what I'm doing here is I created this application. This is essentially a Spring Boot application, which by default, one of the things that we added is we added both WebFlux, which is something that it's interesting. I will say, if you're creating a new project, this could be the cool way to do it. now with Project Loom, I'm is this worth doing it? But this is the Pub House podcast, so we should take that to upheat. But at least so some people know is WebFlux is sort of this reactive framework. We talked about it, I think, a couple episodes ago, and it's a very non-blocking way of creating sort of this REST endpoints or these applications. By default, that's actually much more efficient than the traditional way, which is, essentially asynchronous, where you, even though it's asynchronous, you have a bunch of threads that are sort of waiting, sleeping, blocking, callbacks or futures. WebFlux tends to be, a winner on those particular cases. And the reason why I say I'm hesitating a little bit is because there is a big question mark on for performance, where there's a couple of things that are happening in the JVM ecosystem that we'll definitely cover here when they happen, which is like does Project Loom make Webflux a little bit of less of a reason to move in? There might be other reasons to move to Webflux, but
yeah, I mean we're getting a little bit far from monitoring, but yeah, I think what it comes down to is just Webflux and the reactive framework is kind of decoupling the thread to connection or the thread to request type paradigm, where I need a thread for every single request because threads are expensive, and allows you to just basically try to keep that CPU as hot as possible by having a very small number of threads and a lot of connections, and you just switch to whatever's ready to write and do work.
Yep.
Versus for Java EE or a servlet-based model where, hey, I have a thread. This thread is associated with this request. And as long as this request is going, this thread is married to it.
Yep.
But that creates some interesting things in monitoring as well. And I don't know if we're planning on getting into that, but that's
that's true. But it is something to keep in mind, when you're working it, right? Like if you're using tricks like thread local, those don't work well on Webflux. So we added aside from that, we added what is called the Actuator, right? The Actuator is essentially like Spring Boot packaging for things that are very enterprisey REST type. And one of the things they do is they do put in, like, Actuator will be something, for example, that includes the Micrometer and Actuator endpoints that expose that, right? So once you include these two libraries in your project, then you sort of have access to all the Micrometer configuration that comes. And for example, this is essentially my application YAML. What I'm essentially saying, management endpoint metrics enabled true, that actually makes it saying like, look, I want to expose metrics for this particular project. I want you to make sure that they're ready for me, right? Like, and then the metrics enabled, you can enable each particular, like there's a collection, like you were talking, that there's like this by default, it comes free out of the box metrics. And one of them is, for example, Jvm Metrics. I wonder if there's, you cannot see the other ones.
So, I mean, Jvm would include heap size, the allocation size for your different regions, potentially. I actually don't know if it breaks it down. Number of threads, just things that you would normally see in your JMX, like general sections. This will put into your metrics. And I like to think the Actuator is like the management interface you get for free from Spring Boot. It's basically all the things that we end up building in our applications anyways, if we're trying to get it ready for production.
Yeah,
CPU. Yep.
File descriptor matrix.
We actually covered almost all of them. That's pretty good. Garbage collection. Yep.
Yes. So these are like, essentially they come like almost like free. It's just in there, ready for you to use. So essentially what we're saying here is that we're interested in them and to enable essentially those kind of metrics to be exported. Now, one of the things that and again, this is sort of like the enterprise side of things. Like some people might say, why, if I can get all these metrics, why wouldn't I just turn all of them on all the time? Right? and Bob's smiling because we like that is the first. I don't know if it's the first sort of like newbie mistake you make on these things, but it is something that we all been burned by it. And
I want to drink water from my garden hose. Why don't I just turn it up all the way?
Yeah, exactly.
It'll go faster if I'm thirsty, right?
And I want all the waters. So, so one of the things is that like enabling each one of the matrix does come at a network cost. What I mean by that is like and it sort of makes sense. The more metrics you add, the heavier the payload to whoever is collecting these metrics, right? Like the more sensors you add, the more, the dashboard have to ingest to try to figure out what to display to you, right? By default, some of these are turned off. Like in this particular case, I decided to enable the Jvm Metrics there. And then the other thing that I can do here is that on the management metrics export, I can tell it to sort of like which collector I want to publish to. Right. In this particular case, I have it just hard-coded for you guys to see it, but we're publishing to like a statsd server, which is, this statsd was an actual open source project from Etsy, if I remember correctly, or at least they defined the standard. And it's, when you look at the standard, it's super simple. It's essentially they open a socket, they write up a big string with where is it coming from, what is the metric trying to measure, some gauges and stuff like that, and it's done on UDP, which means that it's not guaranteed delivery, but because like if you manage to lose at sort of like a data point, it's not a big deal, right? So and you see, like I think most of these like data collectors, support or are by default configured for UDP, where if there's some data loss on it, it's not a big deal as long as like that probably means that there's something else going on your application that needs to take care of before publishing metrics. But the idea is that I can keep defining these blocks, which is the fun part. Like, like I publish into statsd, I'm publishing to JMX. I could actually add another one here, for example, if I want to do Prometheus, right? It's here, which is another sort of like data collector. Or if I wanted to, actually, I think there's one for Datadog. So they actually are baked into like this thing. So that's the one that we should try it out, right?
I'm surprised you're not covering graphite since it was open source from Orbitz. Not covering the internal stuff. I just got Freddie in trouble.
Let's say I have a love-hate relation. Like, we used to have this saying, I don't think there's this saying.
For those listening that don't know, Expedia used to be Orbitz, so Freddie's employer is.
It's like I used to work for Orbitz. It got acquired by Expedia, but the thing is, like we have this sort of like saying that in the Smith's house, meaning like the one that actually like Smith's swords, you find knives made out of wood. And what is that saying? Is meaning like, like for people that are consuming graphite from the outside, they probably are doing it very well. But we created it. We sort of have it running, but we haven't paid too much attention to it. So part of it is yeah. But no, graphite is perfectly fine solution. It's another like sort of like statsd intake. Plots the things. Grafana is the one that most people may be familiar with, and essentially it's kind of weird because like all this like APMs or like Grafana, for example, will still need to have sort of like a statsd front end intake, and that usually tends out to be graphite by default, or at least that's the setup that I always seen around. When I see like on the different pockets within Expedia, is essentially a graphite as a collector, even though graphite can actually display the information as well. And then then out of that, Grafana becomes, puts in as a data source the graphite intake that it has. So
I thought it was the opposite. Some in the implementations I've done, Grafana is the graphing thing. It's drawing the charts, while the storage is always somewhere else. It could be Elastic. It could be it could be what's the data, the time-based database, InfluxDB. It could be a number of different things.
Yes.
And it just does the pretty UI stuff.
Yeah, correct. No, I think we're talking the same thing. Grafana.
Yeah. I think I heard you saying the opposite, though. That's the only reason why.
No. You're correct. It's Grafana is for the graphing. Usually, the collectors are either through statsd by graphite, for example.
Sure.
So that's how I've seen it set up. But you're right, like Grafana, you do the graphic and you can choose the data sources. One of the data sources will be like, for example, the influx, like you said, or in our or the cases that I usually run is a graphite collector that it's getting stats.d data. So you can just keep adding them here. And the fun part is that then instead of you having to implement 3 or 4 or 5 of these things, you just add this little block with the information that you need. Like if I wanted to start like publishing to Datadog, I can just do it like this, Datadog. And not that. There you go.
Close.
Yeah.
There you
go. And then there's an API key where you just enter the API key, and then you're off to the races. And that's it. There's a bunch of like sensible defaults. Like for example, what is the intake? Usually there should be like host. We can display the host text a little bit. The URI is already API.Datadog HQ, which is their intake API intake.
Probably don't have to change that.
Yep.
But to your point though, on performance and things like that, the batch size parameter that came up, those are things that can help you optimize some of those problems that you mentioned when you're talking about network being saturated, right, and the penalty you pay for having these things on like that. No, and these are all push mechanisms, right? So this is taking data from my application and pushing it.
And then essentially, it finds out where should I get all this data to. Like in this particular case, stats.d, I put a localhost, but it could have been, HTTPS somewhere.
And the beauty of push is you don't need anything for discovery, right? As long as your source of what's collecting it is well known, or has a single API, or it's public. This is a very simple solution where you just point all your applications at the same thing. You can have consistent configuration, and it pushes it out there. Now, if you haven't scaled it or you don't have load balancing at your collector, this could get very interesting if you start pointing a lot of things at it. That's why there's entire companies that do this. They specialize just basically in drinking from that fire hose analogy that we brought up earlier. But one of the other approaches you can use if you're concerned about your intake or your source getting overwhelmed, and that's the scraper analogy, right? Mm-hmm. So a lot of places will actually just publish an endpoint that has all of these statistics in there in a JSON or maybe a YAML format. Mm-hmm. And then a system will come by and scrape them by calling this endpoint on each application and then pulling them in as needed on some sort of cadence. So the beauty there is you're not, the consuming application is pulling it in on its own time, which means I'm not going to overwhelm it. There's less chances of having things dropped, for example. But the bad thing is now you have to be able to discover where's all my stuff. Because that endpoint needs to be smart enough to say, all right, there's 3,000 applications. They may have a standardized endpoint for everything, but where are they? What if one stops? What if one starts? So you've got some complexities either way. And Prometheus is one of the ones that I'm familiar with that does scrape endpoints, but you're kind of on your own, or you can use different discovery mechanisms depending on what you're deploying to.
Yep. Yeah. No. And that is exactly right. One of the things that we're going to cover just a tiny little bit is the idea of tags and tagging and how that sort of like complicate things a little bit when you're doing it. And like the way that I'll approach this or that I have approached it is like essentially first I turn everything off. I start with even the JVMs. I turn it to false at the beginning, or maybe not JVM, but there are by default, I want to start with what would I want to know. You sort of start designing it from the back, meaning what is the dashboard supposed to look like? And then you sort of start pushing and see for my dashboard to show, for example, my request per second, define it on this tag. That means that I need to publish this kind of stats. Or if I want to know the health of my of the count of my hosts
versus non-production.
Yeah, you get into interesting problems. For example, when you tag by host, like you said, Bob. If you happen to have a service that has 200, 300, 400 containers, Suddenly, if you add in the host key, quote unquote, like meaning the host name, and these are ephemeral hosts, that becomes weird. And at the very end, you realize you don't care about the host name because, like, if you're doing something like a Docker container, the host is ephemeral anyways. So it's just, it's going to disappear. What you want is the aggregates of like all these things together. What do they look like, right? So sometimes when you start by designing what the dashboard is going to look like and then enabling the things that you want, you sort of end up with a cleaner, leaner, meaner sort of like data pushing, if you're pushing, or even if you're polling, you stress the system less, and that is something that a lot of people don't think, or not so much as don't think, but it's like there's usually a lot of concerns that us as enterprise developers have, and we usually tend to skip this part. But if you spend the 3 hours just to clean this up, you're gonna make life of everybody much easier, because
it's not just the systems, it's also the operations
right,
developer, or the SRE, the site reliability engineer.
Oh my
that's
God,
consuming this, because the hardest thing is actually on the human being that has to pull all
support
this.
This.
You may be publishing every little piece of information, but for any given application, maybe only a small fraction of it's relevant, maybe a small fraction of it's worth alerting on. So, I mean, you do want to eliminate the noise up front if there's things that aren't going to add value to somebody. That's, let's say you're monitoring a cache, like an in-memory cache. You're probably going to want to keep an eye on the memory, the heap allocation, garbage collection, all those things. CPU is going to be important, but CPU could mean it's running hot. It could mean you're creating tons of garbage, but that SRE is probably going to be looking at the, the memory allocations. Is this cache full or not, in order to determine what the appropriate action is going to be.
Yeah, and then for example, there could be other things that you don't care about, for example, off heap allocations. Let's say that you don't do any of those because that doesn't happen, or they're so small that you're never going to look at them closely. So that could be something that you say, I don't want to care about that. Don't publish those metrics because I don't care about those. So so that is sort of what the magic, the power of just having this file and describing what we want, right? But now let's see how the actual service will look like, right? So here's the service controller, and this is your typical service controller example where we have a REST controller, we have an endpoint of slash, and then we have a request mapping of hello, and we get a hello service response, right? And the hello service response is a very small object. It only has a message, get message, and that's all there is. So it's almost it's essentially a Pojo, a bean, however you want to call it. So this thing works, right? And this is sort of your stereotypical Hello World program or Hello World REST service, right? Where you can actually go, and then you can just do localhost /hello, and voila, right? So the interesting parts of this is like we said, right? When we get the response, we create a monojust, and the monojust, essentially, this is sort of part of the webflux definitions or the reactor definitions, where you return a mono, which is essentially a emitter of only 0 or 1 elements that are going to be rendered. In this particular case, this is immediate, just because we're not doing a lot of work. We do create response. We do a little thing where we try to record some timers, and I'm going to go over this in a little bit, and then we just return a new hello service response. So the idea with this is, because we expose the Actuator endpoint, we actually have the ability to go and then go to Actuator, right? Oh, no, I didn't want. Yes. There we go. And what this is here is essentially, I decided to list all the Actuator endpoints. So, and essentially because the Springbook actuators, it's like an enterprise. You have info, you have health. Health is a very interesting one, and I don't remember. I think we covered it at some point in time, but if we know, we should.
Yeah, we did. We covered health checks in a previous episode.
Yep.
One of the main things to know is you don't get all of these for free. One of the things in Freddie's YAML file, in his application YAML, he's got the actuator endpoints as star at the very bottom. That enables all the ones that are there on the class path to show up. So as long as you brought in that actuator code, it'll show up. But I think by default, for security reasons, because some of these have some. Don't do that. Hey, let's run a heap dump. Let's make that one public. You don't want all of those exposed.
Yeah, this is like Bob said. Don't put star
this is not a production setting.
Yes. Because they have one you can do a heap dump, you can do a thread dump. There was one that allows you to, which is the one, I think the one to reboot is, let's see.
Oh, I don't remember if you have that one active or not.
I think that one, you have to do more than just whitelisted. I think there is more. Yeah. It's almost like management endpoint restart enabled. So they protect it because they know that could have been very bad. But
health and metrics are generally safe ones. I mean, you may not want it exposed publicly because it's just information that the public doesn't need, but they're generally read ones. And most of these metrics collectors, they're collecting the metrics in one path, and then you're just reading the values as they are.
Yeah. And so one of the things that it allows you to do, right? Like the Actuator matrix, and this is not the way to consume the metrics. The right way to consume the metrics will be for you to go to your StatsD, Graph dashboard. But for this particular, right now, as we're going through, this is, for example, the things that get published in this particular application that we're running. Like, there's JVM buffer count, JVM buffer memory use, JVM buffer memory total capacity. So, for example, process CPU usage, right? Or actually system CPU count. This is kind of like a fun one, right? So I can go here and essentially add it as part of my Actuator Metrics path, system CPU count, and then the number of processors available for the Java virtual machine. And you can see that virtually I have 16. Yes, go Ryzen.
So happy.
Yes. So then you get sort of the last particular snapshot on that particular value, right?
These are all point in time. I think that's the important thing here, that these are not cumulative. These are not anything. These are, when I hit the API, this is what JMX is got stored. I mean, I think essentially all of those are derived from JMX.
And then, for example, this is system CPU usage is 0.09. I'm using 9%. I wonder if I can actually do this. Where I have the my CPU is sort of sleeping right now, but let's see if I can refresh this, and then so it's like 11% this time. Let's see if I can. It's kind of fun. All right, and then I refresh it. It's still 11%, 9%. So I guess it is point in time. It's still varying up and down. Probably encoding all this screen that I'm running right now. So, but yeah. So the thing is, all these came in for free. The interesting ones that we sort of love to look at is HTTP server requests, right? And this, for example, tells me, total time that we spend serving the requests, 3 seconds. There is. Now,
the important thing is that's a cumulative stat. So,
yes.
This is a great example of where a lot of the ones we were looking at before were point in time. This is one that continues to change based on all of the requests as long as this process is running.
Yep. So let's say that I decided to do a couple of refreshes of the hello world, right? I load it up, and now let's see the count value, right? It's 33 right now. I am about to refresh the page, and now it's 43. I essentially refresh this page, 10 times, and then the count went up, right? So that's kind of like, it also tells you like, like, I think this must be milliseconds. I don't think it's taking 4 seconds. Well, maybe it's taking 4 seconds because I do have.
Well, that's the total amount of time, right? So that's a sum of all of the time.
Yeah, you're right. So
you can divide that by the count and get an average. But I mean,
yes.
these are the kind of things you need to know when you're pulling it in and graphing it, and you're aggregating it among a number of different applications. Is you got to know if it's a cumulative or a point in time.
Or is it? Yes.
Because when you're graphing it, hey, why is this time keep going up?
Yeah.
It's like we just keep getting slower. No, not necessarily. It's because that. And wait, the count just went back to 0. Oh, we did a restart. These are things that can become important if you're not tracking and recording those statistics properly.
Yeah. And I think that like for the Actuator, I think because this is sort of like a UI based driven, like I think on this particular case, cumulative, I think that there's a way, or through when HTTP server requests come through statsd, I don't remember if it tries to normalize it or not, but it is something that like Bob says, you should look at what kind of like stat are you getting. Is it cumulative? Is it point in time? Is it a gauge? Is it a timer? Whatever it is, right? And then that should help you sort of like graph it right. Now,
and it could be, Freddie, because your endpoint version of this is tracking cumulative, and when you're publishing, it's, hey, here's 5 more requests, and here are the times for all 5.
And I reset. Yes.
Right. Or here's the average over the 5 that I just recently got, and then it resets. So again, but if you're scraping and you're hitting this, you have to be aware of that.
Yes, correct. So
and often I think there's even resets in here, so there's ways to reset them. I think
to like restart these counters.
Yeah, there might. And now I'm kind of getting a little bit out of my zone.
No, I agree. I think that there's like for again, you're not supposed to use this in production. We're just using this to show like what's in there, right? Like these ones are probably easier to see. Like I guess 5e to the 9. Oh, it's not using any memory, which is kind of nice. But let's go back real quick. Let's do a couple more things because this is going to become interesting. If you look at this, and let me see if I can give it you in a better way, so you can see it. I don't have my indent. Let's see if I can indent it here. New file. Metrics listen to. No, that's not what I wanted. Oh yeah, actually that's what I wanted. And then, come on.
You're just trying to format it.
Yes. And you're
using IntelliJ. I wish I could tell you. I don't know that.
Yeah, no, I'm gonna cheat. I'm just gonna go to the website. Just 1 second. Yeah, then process. There you go. There you go. Okay. So this is essentially sort of like a quote unquote raw, essentially what we're seeing here, but just in a pretty way, right? The one thing that I want that we should draw attention to is this sort of like tags, because that is, this essentially makes or breaks a lot of things, right? So, what the tags are is like every metric that you publish, you have the ability to say like, I want you to add this sort of like dimensions to it, right? Like, for example, let's say that one of the tags that most people will put in is like status, right? Like, in one of the, right now it's telling me that there's 2 kinds of value. There's a 404 and 200 that has been seen or recorded on the Actuator, right? And I can actually specify, for example, I can say, tag equals, for example, and then the name is status, and I want to see everything that got 404 status, right? And apparently there was a count of 1, meaning like somebody, probably me, hopefully me, type something like that doesn't exist, and they got like a 404, right? So now if I refresh this, now you can see that the count went up by one, right? So even though if I take this out, the count is 56, when I essentially filter in by a particular tag, then I only get those particular counts that are part of that tag. And that is sort of like the way that we tend to do a lot of these sort of like statistics. It's not just about the time it took, but sometimes we say the time it took for it when it was successful, the time it took when it was a failure, the time it took when it was going to this particular URL, the time it took when it was going to this other URL. So these are essentially, these tags essentially are like the dimensions of that particular metric that you do. And this is a different concept than what most people think, because one of the things that happened when I was trying to create this is I created a success count. I created a success count, a failure count, a success count for this URL, a failure count for this URL. And suddenly you have like this 30 or 40 like things trying to coordinate or trying to like keep track of like, was it successful then? +1 on this one. Was it a failure? +1 on this. Like a lot of these micrometers solve this by just you add the tags, which is the dimension that you want to record it in. And usually things like Graphite or Grafana will be able to give you a breakdown filtering by that particular tag.
Yeah, but this is nice. If you're just developing locally and you're trying to solve a few things, you can use the, this is almost like a facet in a search application, so it's like status is a facet and I just want to see what's under 404. Some of that is built into the API. So if you don't have your big aggregation view that's supposed to make a lot of this easier, your APM that's supposed to, consolidate all this, you can use some of this stuff to get you by, in the meantime.
Yeah, no, and even when you use an APM, a lot of the times you may do, like, for example, in Influx, you do group by outcome, right? You can say group by this tag, and then you have essentially two graphs, one for the success, one for the failures, and then you can sort of like start comparing it. So that's the beauty of it. Instead of trying to graph two different metrics, you just say, oh, I want you to group by this tag, or I want you to sort of like slice or stripe by this other tag of status, and so all that stuff. Now, all this came for free on our service controller because we just declared it as request mapping, and that just worked. But one of the things that sometimes we like to do is have more control over it, right? Like there might be things that are not as necessarily on a controller. There might be things internal that you want to keep track. So you have the ability to create your own sort of like Bob says, you create your own sensors, right? So this is going to be like the easy one, which is we're going to create a timer. And the way all these things work is Micrometer will have what is called a meter registry. Now, the meter registry is essentially the place where it's sort of like it's known of all the sensors that you have. It's a place where you tell it, I'm going to record these sensors. I need you to create a new sensor. And the meter registry then is the one responsible for every time it needs to publish or when it's pushing, or every time somebody polls, when it's like, polling that information, the meter registry will say like, oh, I have all these meters. Let me get the information out, get it ready, either push it out or get it ready to be served. So in any application, you always have this accessible somewhere. Either you create one yourself, by default, Spring will look at, for example, your application YAML and say like, oh, you're exporting to StatsD, JMX, Datadog. So that means that it's going to create a composite meter registry that has this particular implementations for StatsD, meter registry for StatsD implemented, meter registry for JMX implemented, meter registry for Datadog implemented. So once you have one of those, the interface will have something like .timer, which allows you to create a particular type of meter, which in this case is timer. Timer does exactly what you think it will do. It's just for recording the timing of things, right? So once we create this, meter registry.timer, we give it a name called response timer, and then we sort of assign it as one of our private fields in our service controller. Then we have access to it where we want to use it. In this particular case, I'm trying to we don't get distracted by this. This is not working right now.
I was going to say. Yes.
So
or the smoke man behind the mirrors.
Yes. There were many tries to get graphite working. So here we're creating a response, and let's say that creating a response in this particular case takes some time, right? Like for whatever reason, you're consulting on the 3 web services and you want to know how long it took to actually create the response. So in this particular case, I can do timer record, pass in a runnable, and then in the runnable, in this particular case, I'm just doing a thread sleep of something, so there's something more interesting that's 0.0001, right? Timer has other things, like for example, timer dot, you can record by just passing in the duration. If you happen to do like a stopwatch or stuff like that, and you are the one who, instead of passing it a runnable, you just wanted to pass in, record this time because I measured it somehow, some other way before, right? There is also the ability to where is it, like tags? Oh no, the tags are created on I guess they're created on here. Yeah, here you do the tags. But I'm gonna put a pin on that one, and then we go revisit it. But for now, this is essentially when you click record, sleep random, and it then returns a response. Now, if we go back to the actual actuator, you'll see that in the actual metrics, there should be a response timer metric, which is right here, right? So if we look at it, then we can see that the total time was around 5 seconds or 5. I think
that's cumulative, right?
I think so, yeah. So let's see
you
what
divide that by your 19 to get your average.
Yes, so actuator, no, let's see, hello. So let's do a couple more of these. And then this is, now it's 7. So divided by 25, and then you should get around, 250? Let's see. So 280, which is, well, I kind of sort of expect because this is a 500 milliseconds. So if it's a random, sometimes it'll be around 0, other times it'll be around 500. 250 should be by average, right? So the fun thing is that this is essentially completely in your control. You can create as many of these as you want. Like when we're talking about tags, when you create the timer, here is where you actually put in the tags that you want to say. For example, let's say that I just want to do, for this particular case, I want to tag this as success, true, and then put in some, other, let's say that these are the tags that I want for this particular timer. And then let's see if we can sort of like redo this. And let's see. There you go. And then,
but yeah, I mean, I think probably one of the best place to put some of these timers is within your service classes, because again, if you're using Spring as a framework, a lot of the controller stuff is going to get instrumented by the URI path automatically. But most of our controllers are decoupled from services, other API calls that are aggregated together. And frequently, we might have a service that's running slow, but really the service is just a conglomerate of all the other things that it's doing. So we're in production. We don't want to have to instrument everything in production to try to find where it is. So if I'm able to surround my services with these calls, I'm able to differentiate which part of the service is the slow part.
Yep. And so, like, for example, in this particular case, right, like I had the response timer, I added my tags. Now I can see it success, and the values are true because essentially that's the only timer I created with that tag, but I can have other timers created with a tag of success false. And then if that's the case, then I can actually do the sort of like this tag equals success true. And that way, I get that particular count, on the events that happen. And this is sort of like the way you have to think about this. How can I use tags instead of trying to create different counters with different names? Because doing the tags allows you to do things like, oh, I want to see total of like all total requests, even if they succeeded or failed. That's kind of like a hard thing. If the timer is different names, it's not that it's impossible, but you're making everybody do more work, because then you need to create two series, you need to add them together. And some of them makes it a little bit easier. Some of them make it a little bit harder. Instead, every sort of like graph dashboard, Datadog and everybody else, it makes it super, super easy if you just decided to do filter or slicing by a particular tag value. So,
what if I wanted to put you a bit on your feet, make you work on your feet a bit? And I said, well, this is probably the more interesting one, where I'm getting over time. This is the count and this is the total time, so I can compute averages. What if I wanted a point in time metric, like, hey, this was the last random number generated?
Aha. So we actually have another type of these are usually called how do they call? They are called.
Are these the
metrics.
Gauges?
Yeah. Actually, that'll be a
counter.
Yep. Well, it's no, you're right. It's a gauge.
I think it's a gauge. Yeah.
Yep. Yeah. Last random number, right? And then let's see, name, string name, and then we need a number. What's the number for? All right, fine. Let's see. A value of number, thread simple number used to access
the value.
Oh, so I guess.
How many of them? So maybe one.
Long. No, but it's
I think it's an implementation of number, though. So isn't it the actual? Yeah.
Yeah. So there it is. Gauge equals that, and then we make it created.
And I'm making Freddie do all this on the fly. I didn't talk to him about doing this beforehand, so I'm just being a troublemaker.
Yeah. No, that's super interesting.
But I mean, a gauge, the difference between a gauge.
Oh, I see.
Think of your gauge as like your speedometer. The speedometer is going to tell you how fast you're going now versus how fast you've been going over the past 10 minutes.
Yes, it's an instant. So gauge, and then there you go. Then nope. There you go. And then this is essentially one, and then what is it doing now is essentially every time there's a publish, the meter registry will look at what value is on gauge, and this is essentially an atomic launch. So it knows how to sort of like get it from there. So if this works right, then this here is noise, and then gauge set noise. Now I think that should work.
Give it a shot. Keep the fingers crossed.
Yeah, there it is. Oh, I didn't realize that atomic load implements number. I guess so.
I guess that makes sense.
Yeah, it does make sense.
But yeah, I didn't actually know that off the top of my head either.
Yeah, no, it's like, because I never used it as a number, but.
No, yeah, I think for me, it's always been some sort of a counter.
Yeah, run, and then a debug. Now let's see if the demo gods are with us today. Let's see. All right, so let's do a couple of these.
Yeah. And we'll go back.
And then let's see. And then.
All right. Well, let's see. Is it there?
What
do we name it? Response time or last? There it is.
It is there.
All right. Good.
So let's see.
It works.
And then let's see. And that was 312. And then 149.
There we go. Look at that.
That took a little time, so they should be higher. 344. Look at that! Oh,
boom,
we are so good. But yes, so the idea with the gauge is that you put in essentially a place where it knows how to get the number that you want to publish, right? So it could be active number of users, right? Or, maybe something like that. And you put it into a particular, atomic long or atomic end, whatever it is that you want. And then every time that we publish, it just reads that particular value. Again, it's a point in time. So you do have to, these are not things that has historical significance. It's just that at that point in time, this is the value, and that's what it was.
Right. But if you have a graphing application or you have a metric store or collector, this is a good way to track those things, and then you can graph them a lot easier than trying to have to figure out, oh man, okay, well, I'm getting an average number. I can actually get the point in time numbers and then get a more accurate readout if that's what I'm looking to do.
Yep. The counter is almost like the one that we saw. I'm not going to implement one, but the counter is essentially the one that we saw on this one, right? So
number of requests. Yeah, it's just an increment. It's going to keep going up,
keep
and
going
up, and up, and up, and up.
Yeah, and the interesting thing. So there's like 3 or 4 things that I think I wanted to cover is that because this is a very common problem. A lot of like you don't have to do like Bob said, you don't have to do this for any of the Spring Boot annotations, and even if you're using something like Quarkus or Micronaut, they probably have something like that. Like search for it before you.
Most of them do actually have a Micrometer kind of implementation, and for most actually, I know for Quarkus it even states on the website this is the preferred metrics tool for the framework.
Yeah.
Again, it's very popular. It's fairly standardized, and I guess one of the most notable things that I think you've demonstrated with your demo tonight, Freddie, is how little you actually have to know to do a lot. I mean, yes. So it's you did 2 API calls between Gauge and Timer, and I think 90% of folks' metrics that they want to track, their use case are covered in those 2 things.
Yeah. No, and that is the thing. Like the other one that I was gonna let's see again if we get angry the internet gods again. I'm gonna push my luck. Like if you're working on WebFlux, if you happen to be working with a lot of the mono stuff, there is a way for you to let's see. See, and then this is called mono name. Oh, it did. Okay. Oh, this is fun. Okay, so the one thing that we did is like I give this mono a name, which is something weird in the sense that if you see that name that you're naming the mono, but it doesn't tell you. Well, actually, it does tell you. There it is. And the give a name for this sequence, which can be retrieved by its kind of name. So it's the first. If metrics operator is called later in the chain, this name will be used as a prefix for the meter's name. So if I give it a name and then I call metrics, then what will happen is when I go to here and refresh this, the mono now is recording.
Look at that.
Different. And then, for example, it tells me mono name flow duration, which is description times where duration lasts to subscription to the incomplete. Total time should be very, very little because it's almost like a media call. It's a mono just. But we also have, what else we have? We have subscribed, which is how many people or how many things are listening to this. And this should be, I guess it just said
5. That surprises me because I would if it was the number subscribed, I would have thought.
Oh, it's
so it's how many it's been subscribed to.
Yeah.
So it's almost in this case because it's HTTP, it's just requests. Yeah. It's another counter. But maybe if you were doing something that was non-HTTP and it was happening asynchronously, then that might be interesting. Yeah.
And like there will be other things. I think like if there is like let's say for example, I think that if you do something like then if
Freddie's really pushing his luck tonight because he got a few things working and now he just wants to show off.
No, I am just I think there's the ability for you to also track like Like if there's, for example, right now, because we're on the happy path, then there's only like subscribe and duration. But I think there's also like error count, status. But because we never had an error in our mono,
it doesn't get populated unless you hit it.
Yes. So that is okay. Maybe you're right. Maybe I won't do that right now. But the idea is that that you can, even for like this, if you're working on Webflux, then mono sequences have the ability to add name and metrics. So all of them are ready for you. And we cover, I think, the most interesting ones: timer, gauge, and there are other ones that there's counter, which is the ones that just keeps that running count of things. If you want to see how many times you have to do file reads or stuff like that, maybe that's something you're interested in.
Yep.
But those are really like the main things. This used to be very hard to do, like or not hard. Let's put it. It used to be not as easy as it is today. So with this very simple application YAML, you describe all these things. If you really don't like even if you're not using Spring, you need to create your own. You just have to get a meter registry, and then out of that you create your timers, you gauge your counters, and that will just give you the ability to have them in there. And I think the implementation of the meter registry will be the one that, for example, like if you want to do this essentially quote unquote the manual way, right? There's a Dropwizard meter registry if you're using Dropwizard, a logging meter registry which will publish to essentially your SLF4J. Yep. Step meter registry, and then out of this you need to also bring like the one that you want for example like stats for like statsd or InfluxDB.
So.
Right?
So what you're telling me is I can remove all those stopwatch statements and all the times I'm calling system time and subtracting it from the last system time. I don't need to do that anymore?
No, you just pass it into a timer.record and you got it.
I like it.
That is just makes it so much easier, isn't it? And it's all done for you. It not just records, but publishes. It figures out the rate that you need to publish. It figures out, the best way to sort of like aggregate these before publishing, all that stuff, which is, if you think about this problem from like if you had no help from whatsoever, you start running into this, like what should be the rate that I need to publish? How can I consolidate these things? How can I slice information? All of that has been figured out by I'll admit people that are way smarter than me, and it just works. So just the beauty of the Java ecosystem is that we can just take these things and run with it. So we encourage everybody to do that. Don't reinvent the wheel. There's so many like timer stuff, and then the other ones that I think I'm gonna go over, and then I'm probably gonna put the show notes. There's also like the ability to do time, which is I tried to make it work before the end of this show, but it was giving me problems because I think the target was not identified properly. But like even just doing like these annotations and methods will allow you to get the time it took for doing a create response. So let's see. Right, but and so in that sense, just rely on what is in there. Don't create like if you're using Spring, don't create these things. If you create your own timers, use them through Micrometer instead of trying to create your own thing. And last but not least is like do rely on the tags. Tagging is the way that we do these things because all the ingesters and graphing sort of like dashboard displays work very, very well with these. So that's really about it. So
That's quite a bit.
But yeah. So we accomplished a lot. I think that's what we have. We can probably start publishing these in the repository somewhere. So.
Yes.
We'll put it on the show notes, and that's it. All right. Happy programming, everyone. This is Freddie signing off.
This is Bob signing off. Follow us on Twitter. Java
All right.
House.
at Java Pub House. Thank you, everyone. Bye-bye.